Mr. Balk solving this problem out loud. Okay, let's see. ln of n over n plus 1. Over n plus 1, that looks like a 1 over n, which is a diverger. And that ln of n does not help me at all. It makes it blow up even quicker. This thing's going to diverge. I already know it's going to diverge. Okay, so I want to somehow look at it versus 1 over n plus 1. Okay, let me think here. The blue guy's bigger because he has something on top. Okay, let me do a quick direct comparison test. Let's see if this is going to work. This guy is red, and here is blue. I think red diverges. Now, I haven't shown that yet, but I'm pretty sure red diverges. So if red diverges, blue needs to diverge. Good, that's what I predicted over here. Now, I haven't fully shown that red diverges, but I know it does because this guy's just like 1 over n, and I'm going to do a limit comparison test, 1 over n over 1 over n plus 1. That gets me n plus 1 over n. The degrees are the same. That goes to 1. So they both diverge. So that diverge tells me he diverges, which tells me he diverges. So I used the limit comparison test to get to here, direct comparison test to get to there. Good. What's up? 1 over n plus 1. Yes, C. So then, instead of all of the black that I just did, you could take this, go, let me integrate from 1 to infinity of 1 over x plus 1 dx. That is ln of x plus 1 from 1 to infinity. That blows up. He diverges. So since he diverges, yeah. Okay. So you see how you guys are starting to now realize that you definitely know red diverges. You know that. You're starting to go, I know red diverges. Now, for AP or for a problem or whatnot, you need to show me why you know it. So some of you might go, I know red diverges by the green integral test. Some of you might go, oh, it's basically 1 over n. That's why it diverges, so I'll do a limit comparison test. Do whatever it takes real quick to show that this guy diverges. And once you know that that guy diverges, you have the direct comparison test with blue right there for you. A little better? Okay. Hopefully. Let's see, what else does Bach have? Okay, so just stare at this one. This is, I'm not doing any work. I already just set this up. What's your gut saying? Converge y, maybe. Who's the main guy here? N squared. So just think through the thought process. Do you agree that green is smaller than red? Okay. Green's smaller than red. So in my little world here, I got green, and then I have red is bigger than him. Okay. If green diverged, what would red do for sure? Diverge. But let me see. What would I have to do with green? Are you pretty confident right away that you know green converges? Do you know how you need to show it though, right? So who might you compare it with? 1 over n squared. And when you do that, you get 1 over n squared all over 1 over n squared plus all this stuff. You get an n squared over an n squared. What's that go to? 1. Do you see how quick we're doing this now? And so he converges by who? Why does he converge? P series. He converges y. Limit comparison test with him. You guys agree? So do you now know or agree that green converges? Okay. Now, is that good? Do I know anything about red yet? No. But do you see how quickly you got through green and how quickly you got through black? Guys agree with that? Are you okay with that? You're going to get mad at me because I'm not going to solve the rest of the problem here, but did you get through green quickly? Green and black. Focus on green and black. Did you do green and black well? That's all I care about right now. You're not ready for the whole toolbox yet, but did you get through green and black well? Do you understand why you can't tell me red yet? Cool. Because it's bigger than green, and green's a converger. What's that? Yeah, if this guy If he was a diverger, he's a diverger.
Okay, so if like the power under the ln was like not 2, 1,
Yeah, and we did that one right here.
so we just like assume that if the power, like if it doesn't like converges.
Nope. Yeah, thank you. Okay, try this one.
They said that generally, if it was a converge, that's good. If it was a diverge, that's probably bad. If it was diverge, obviously bad.
This is a diverge converger.
Probably bad.
Probably bad.
So you can assume that if there's a diverger in the problem, it's
Probably bad. Yep.
Yep.
Yep. Okay, was this one of them? Okay. Okay, I'm going to do the Bach way again for you to just hear how I think through a problem. Okay. All right, so I don't like negative exponents. So right away, I am going to look at that. Okay. There's a lot going on here with the n and the squaring. I got rid of the negative, which is nice. Now let's see if I can kind of get rid of the squaring. See how I got rid of the squaring part. Who's bigger? Right one. Here's how you know. Let me ask you this. First question, when I always ask you who's bigger, I first want you to look here and say who's bigger. This guy on the...
But since they're flipped.
Yep. That's the best way to answer who's bigger. First look at the bottom. The left guy is bigger on the bottom, which means he's smaller overall. Better? Now, this blue guy, I'm going to play with this blue guy now. And I see the blue guy as that. What is that? Geometric. So he does what? Converge. So right away, I'm going to draw a picture. I have the green or the blue guy is here. He's a converger. And the green guy is tucked underneath. Yes! Why is it good that I tucked him in bed? By direct comparison test, he also converges. Good, done. First off, Scott, the name for what? Yeah, yep. You? What's your question? Limit with who? These two? Okay. Okay. So let's try limit comparison test. I got 1 over en squared all over 1 over en. That is en over en squared. Can I do anything with that? Or ask this, who's bigger, top or bottom? Bottom, so where does it go? Goes to 0. Ah. Okay. So you guys starting to see why yesterday you liked limit comparison tests. Now I'm starting to show you on purpose some of them that don't work. That doesn't mean it converges or diverges. It just means I don't know.
So do you do like
If it's small things, yes. Like if it's I only have to remove one little piece to it and I can clearly see who's bigger or smaller. On things like this, green to black, especially if there's some like one of them is a minus and one of them is a plus, it's a lot harder to tell who's bigger or smaller. So if I can tell who's bigger or smaller really quickly, use them. If not, try the LCT. Okay? All right, moving on. Notes, here we go. Current toolbox. You know all these things, okay? 1, 2, 3, 4, and yesterday I added 5 and 6. And each one of them, as you've witnessed, has its own flaws, okay?
The divergence test the same as the test.
Yeah. All of them you've noticed has their own flaws, okay? And that's why you have to build up your toolbox, okay? Currently, one of the biggest flaws on all of them is every single one of these problems had all of the terms be positive. That's not always the case. So in a case that you have negatives as well as positives, I'm going to teach you a new test today, and that test is called the alternating series test. So when you go plus, minus, plus, minus, plus, minus, okay? So again, 1 through 6, everything there was pretty much everything was a positive term. Now I'm going to have these sequences that jump above the ground and below the ground, up and down, up and down. So alternating series test is this. You are going to love it. I'll let you write it down first, and then we'll go from there. Okay, biggest thing is this. You need 2 things for this to work. You need to go to 0, and you always need to be decreasing to 0. Okay? So you always need to decrease to 0. Now, notice when I say that, you might go, how can you do that when it's alternating? Am I taking the alternating part of this or just the main part to this? Notice, this here, when I highlight it, this is the alternating parts. This is just the terms. What needs to go to 0 directly? The alternating part or the terms? Just the terms. So the only thing that matters is just the terms. The -1 to the n thing just means, oh, the signs go back and forth, whoop-de-doo. I just care about the thing itself. Okay? So take a look at one like this. Okay? -1 to the n plus 1 times 1 over n. If you write some of these out, let's see, if I plug in 1 first, that's even. So I get 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus, you get the point. Okay? Do you see how it alternates? So it's alternating. First condition, what's the limit as n goes to infinity of 1 over n? Notice, I'm not worried about the alternating part, just the core part. That goes to 0. Good. Next thing is the next guy always smaller than the first guy? Is this smaller than that? Cool. So, did both conditions get met? So what happens to this whole series? He converges by the alternating series test. Now, notice, this is called, I told you I want you to learn some names. This is called the alternating harmonic series. Didn't we just a couple pages ago write what the harmonic series was? What's the harmonic series do just by himself? Diverge. So realize this diverges, but if I put it in with the alternating part, what does it do? It converges. So if it's alternating, it converges. If it's not the alternating guy, it diverges. Okay? Realize the difference there. Okay? Yep.
So, I just a little confused about series versus sequence. So I know that series is when it's being added up, and sequence is just when it's terms. So
these dots are the sequence. So if I plotted those dots, they look like this. 1, -1/2, 1/3, -1/4, 1/5, -6. It goes like this. The dots that I just gave you there are the sequence. The series would be add that rope to that rope to that rope to that rope to that rope. It's a minus, yep. Because it's like adding this rectangle, subtracting that rectangle, adding this rectangle.
and then if the series diverges,
It blows up, meaning I sum. Yep.
or it's number.
Yep. But my sum of that sequence blows up.
Because I don't know anything about where the sequence goes based on whether the series
Correct. Correct. Yep. Sorry. No. For the most part, if you have a diverging guy and I make him alternate, most likely he's gonna converge. And the reason why is this: this guy here that I just drew you is box minus box plus box minus box plus box minus box. Okay, is it okay with that? Do you see how that minusing part kind of controls him a little bit? Versus if I did not make him alternating, it would have been box plus box plus box plus box plus box. Do you see how the adding up of the boxes could be a blow up? But the alternating part always kind of tempers you. Plus 10 minus 8. Plus 6 minus 4. Plus 2 minus 1. You see how I can't blow up? Okay? Let's look at this one. Okay? This one looks a little bit more confusing with a lot more stuff to it. Okay? So what I'm going to do is I'm going to peel off the alternating part. I'm just going to get the alternating part to be a -1 to a thing. So are you okay with that part? Instead of it being -2 to the exponent, it's going to be -1 to the exponent, and then the 2 to the exponent by himself. Now you can argue with me, shouldn't that -1, where should it technically be? In the bottom. But all that -1 is doing is what? Alternating. It's the only part. So does it matter if it's up top or down low? No. You guys okay with that? So yes, this part here, if you wanted, could be down low, but I don't care. I just got the alternating part there. The part I care about is the AN stuff, the terms. You guys okay with that? Okay, so let's look at it. Since it alternates, I only need to care about two things. First thing, I need to see if it goes to where? What do I hope it goes? 0. So right off, I plugged in infinity, and I got infinity over infinity. I don't know. Can I take the derivative? Can I hope you tell this? Yep. Yep. Derivative up top. 1. Bottom. Stamp. Address. Ink. What's that go to? 1 over infinity, which is? Good, that's step 1. That means my alternating part is going towards 0. That's good. The next thing I need to check is what? And what does a of n plus 1 always have to be, hopefully? Less than. Now stare what I did. Did I do the n plus 1 guy on the left and the n guy on the right? And right now I put a question mark there because I don't know. I'm just hoping that he's always smaller. You guys okay with that? If I can tell you that he's always smaller, then am I good? Okay, so let's simplify a little bit. I got to that. N plus 1 minus 1 just goes to an n for that bottom left guy. Think of the question mark as like an equal sign right now, or a greater than sign, or a less than sign. You can cross multiply and solve with that sort of thing. What did I just do? Move this guy over, because again, that question mark's like an equal sign. How many 2's cancel? This is 2 to the n. This is 2 to the n minus 1. 2 to the n minus 1. So how many 2's are left? 1, 2. Where is he? On top. Is okay with that? Okay, let's see. It started, where did it start at? N equals 1. So when n equals 1, I get 2 and 2. When n equals 2, I get 3 and 4. N equals 3, I get 4 and 6. Who's bigger? One on the right. Bigger or equal at the very beginning? Is that okay? That's the goal. So am I going to 0? Are my terms always getting smaller? So what happens to the whole thing? Converges. What's up? No, you would. I would probably go down a little bit because here, once I see the pattern, I can guarantee you if I plug in 5, 6, 7, 8, 9, 10, I know that the one on the right's bigger. When I plug in earlier, and at least for me, I might not necessarily I know for sure who wins yet because I don't see the whole pattern yet. But when I got it simpler, I feel a lot better to say I know 10, 11, 12, 13, 14, 15, they're always going to win. Okay? Like you could have even, if you wanted to, how about this? Let me do even one more step. Could I subtract n over? This is going to be better. Let me subtract n over, and what would I get? 1 question mark n. This is way better. I like this one better. Who's bigger? Do you agree without even doing any work? I know that one's bigger. So I would try and simplify down so then I have like a statement that tells me for sure I'm bigger rather than just plugging in a couple. Okay. Okay, here. Is it alternating? Okay. So then I worry about n plus 1 over n. What's that limit? Is that good, bad? Bad. That, all that means is test doesn't work. Does that mean it diverges officially? No. Just means I need another tool. It does not mean it diverges. It means my tool just doesn't work. Do you guys hear that? Okay. So if you don't get it to 0, that just means, oh, I'll teach you another tool someday. Okay. Try out, just stare at some of these while we load the next video. Look at some of these. See if you can kind of figure out what ones work and don't.